as promised, you may have a question on differentiation, almost certainly will. It may come towards the end of either the paper 3 or the paper 4, but you're almost certain to get a question on differentiation. And last year, in May of 2016, we had 2 good examples. This was on one of the paper 3s. This was on the other paper 3. So, how do you differentiate? First thing is not to be too scared of the whole thing. This is what you're likely to see when you have to differentiate. And we'll refer to that from now on as dy by dx. And it's a little bit like thinking about this. When you find the gradient, you find a little bit of y over a little bit of x. And that's all you have to do. And that's really what it is. It's telling you what the slope is. But there's also a trick. And your curves will always at this level be powers of x. Notice, to the power 3, to the power 2, to the power 1, to the power, that's 0 in case you don't know. So it will always be powers of x. And what's the rule? Let's clear those out of the way. And the rule is this. To differentiate dy by dx, all you do is take the power. So we'd start with something like y equals x to the power n, let's say. You bring the n down, and it becomes dy by dx equals n x to the n minus 1. Let's do a quick example for you before we tackle the ones we've got to do. So in this case, let's say y was equal to x to the power of 4. So dy by dx would be equal to 4x to the power of 3. That's not too hard to learn for easy marks. Let's try a slightly more awkward one. Let's try y equals 3x to the power of 2. Well, that 3 doesn't get thrown away, but when you bring down the power, it will be 2 times 3 times x, knock 1 off, to the power of 1. So that becomes 6x. So if you can master that little technique, you can get some easy marks. So let's try the example that occurred last summer. Here we have dy by dx. Bring down the 3 in the first example, and it will be 3 lots of x to the power of 2. I'm following the rule I have up here. The next one is bring down that 2. Now be careful, you already have a minus there. That 2 is going to come down, multiply by 9 over 2, and then it will be times by x to the power 2 take away 1 is 1. The next one is there's a minus 54x. Now the power there isn't stated, but of course that means it must be 1. So it will be 1 times 54 x to the power of 0. And a little hint here, all constants will disappear when you differentiate. So the 10 just disappears. It's basically because the power of x is 0. But we can get rid of that. We don't need to worry about any constants. So we've got our answer. We just need to simplify it. So this will be 3x squared. Those 2's would cancel. Minus 9x. 1 times 54 minus 54. And of course, x to the 0, as I've said just now, is a constant, is 1. Now the question says this curve may have 2 turning points. It does have 2 turning points, sorry. And so you've got to find out where they are. Well, turning points are like this. That curve has 2 turning points. There's the turning points. They change direction from going up to going down, or going down to going up. But if you imagine that was a ski slope, your ski would be flat at those 2 points. In other words, it would have a slope of 0 at these 2 turning points. Well, we already have a formula for the slope. We've just calculated it. So essentially, you need to say that at a turning point, our formula for slope must be 0, and you have to solve that. Now again, you have, as one of your more complicated questions, tackled factorizing quadratics. So let's try here. Straight away, you could divide by 3. You could make it a lot simpler. 3 into 3 goes 1. 3 into 9 goes 3. And 3 into 54 goes 18. We could factorize that. You've been doing this in the basic algebra section. So that's an x. And we want two numbers which multiply to give you minus 18, but add together to give you minus 3. There's our answer. So now we know that we could have x minus 6 is equal to 0, or x plus 3 is equal to 0, in which case x could be 6 or x could be minus 3. And that's an easy way to get some marks. Now, the, if you like, nasty side of this is that they may ask you something to do with applied maths, and they may ask you something to do with speed, distance, and time, and also acceleration. And the thing to remember for this kind of question is, if you've been given something called displacement, that's distance, then you're asked to calculate velocity. And if you think back to the formula you do know, speed equals distance over time, then that may help you remember that to calculate velocity, you find a little bit of distance over a little bit of time. In other words, ds by dt. And the same process as before. So again, we would then go 3 times by 2, t to the power of 2. Notice the 3 comes down, multiplies, knock 1 off the power, minus 2 times 12 times t to the 1. And here, of course, it would be plus 7t times by 1, of course, t to the 0. So our velocity is 6t squared minus 24t plus 7. T to the 0 is 1. And that's your answer. They don't ask you to find where the velocity is 0, which would have been the same as in question 1. Instead, they take this a little bit further. And now they want the acceleration. Well, the acceleration is how fast you're changing your speed. So if you change your speed, that's dv by dt. And again, you simply differentiate this function. So the 2 comes down, multiplies by the 6, and that leaves you with t to the power of 1. The 1 that is there comes down and multiplies by the 24, t to the power of 0. And of course, as before, the constant will disappear. So you're left with 12t minus 24. Now, to finish the question off, you've done 2 lots of differentiation and the trick's been used 5 times there, very easy marks, but it then says, find the time at which the acceleration of the particle is instantaneously 0. 0. Hang on, this is a slope. Maths differentiation gives you a formula for the slope. In other words, when is this 0? So all you need to do is put that equal to 0, rearrange it, and the time is 2 seconds. And your question's complete. Easy to get marks, And I think that covers most of the types of example you may have to deal with. So good luck getting a few easy marks.